The more we learn about 3I Atlas, the harder it becomes to call it natural. Every new observation adds another layer of impossibility. Every detailed image reveals patterns that should not exist in random geology. Every measurement produces numbers that defy our understanding of how objects behave in space. And the latest Hubble Space Telescope observations, released just this month in February 2026, have revealed something so geometrically precise, so mechanically regular, that it challenges even the most conservative astronomers to explain it through natural processes. Hubble has detected what scientists are calling a triple jet wobble pattern. 3 separate jets of material, spaced exactly 120 degrees apart in perfect geometric symmetry, oscillating back and forth with clockwork precision, not randomly, not chaotically, with a measurable period, with consistent amplitude, with coordination that suggests either impossible coincidence or deliberate control. Before I explain what this wobble pattern is and why it matters so profoundly, I need to establish exactly what Hubble has been observing and why these latest images represent something fundamentally different from anything we have seen before. The Hubble Space Telescope has been tracking 3I Atlas since early January 2026, conducting regular observation campaigns as the object moves through the outer solar system following its closest approach to the Sun. These observations have been some of the most detailed imaging of an interstellar object ever conducted. Hubble's resolution and sensitivity allow it to see features on 3I Atlas that ground-based telescopes simply cannot resolve. The images reveal jet structures early on. We have known since January that the object was producing multiple jets of gas and dust emanating from its surface. Initially, astronomers identified 4 distinct jets. 3 of them were arranged in a triangular pattern, evenly spaced around the nucleus. The 4th was the infamous anti-solar jet, pointing directly toward the Sun in violation of every principle of cometary physics. That configuration alone was extraordinary enough to generate significant scientific debate. But the February observations revealed something that the earlier images had not shown clearly. The jets are not static. They are not fixed structures pointing in constant directions. They move. Specifically, the 3 symmetrically arranged jets oscillate back and forth around their average positions with a regular, periodic motion. The wobble has a measurable amplitude of approximately plus or minus 20 degrees from the central axis of each jet, and it has a period of exactly 7.1 hours. Every 7.1 hours, the jets complete one full cycle of their wobbling motion. They swing one way, reach maximum deflection, swing back the other way, reach maximum deflection in the opposite direction, and return to their starting positions. Perfectly regular, perfectly timed, perfectly coordinated across all 3 jets simultaneously. Let me explain why this is genuinely impossible for a natural object. Comets produce jets when solar radiation heats ice deposits beneath the surface. The ice sublimates, turning directly from solid to gas, and the expanding gas bursts through weak points in the surface layer, creating visible jets of vapor and dust. These jets are controlled by several factors. The rotation of the comet, which causes different parts of the surface to face the Sun at different times. The distribution of ice beneath the surface, which determines where jets can form. The strength of the surface crust, which determines where the gas pressure can break through. All of these factors are inherently chaotic and irregular. The rotation rate of a comet is not perfectly constant. Internal mass distribution causes wobbles and precession. Surface properties vary from place to place. Ice deposits are not evenly distributed. The result is that comet jets are messy. They turn on and off as different areas rotate into sunlight. They vary in intensity based on how much ice is available. They change direction as surface features erode and new vents open. What you do not get is perfect geometric symmetry. You do not get three jets spaced exactly 120 degrees apart, and you absolutely do not get synchronized oscillation with a precise period. That requires coordination. That requires a mechanism that can control the direction and timing of material ejection from multiple locations simultaneously. Nature does not provide that mechanism. Engineering does. Let me walk you through the specific observations so you understand exactly what Hubble detected. The February imaging campaign captured 3I Atlas at multiple points during its rotation cycle. By taking images separated by several hours and tracking how the jets changed position, astronomers could measure the wobble pattern precisely. The data shows that each of the three symmetric jets sweeps back and forth in a cone around its average direction. The cone has an opening angle of about 40 degrees total, meaning the jet moves 20 degrees to one side, then 20 degrees to the other side. The motion is smooth and continuous, not jerky or irregular. This suggests the wobble is not caused by discrete venting events, but by some kind of continuous process that varies smoothly over time. And here's the detail that should make you stop and think very carefully about what this means. All three jets wobble in phase with each other. When one jet reaches maximum deflection to the left, the other two jets are also at maximum deflection to the left relative to their own axes. When they swing back to the right, they all swing together. This is not three independent processes happening to have similar periods by coincidence. This is coordinated motion that requires either a shared physical mechanism linking all three jets or deliberate control synchronizing them. The period of 7.1 hours is also significant. That is very close to the estimated rotation period of the nucleus, which has been measured at approximately 6.3 to 7.5 hours, depending on which observations you trust. This suggests the wobble might be connected to the rotation of the object. Perhaps as the object spins, some internal mechanism causes the jet directions to vary in a regular pattern. But here is the problem with that interpretation. If the wobble were simply caused by rotation bringing different surface features into and out of activity, you would expect the jets to turn on and off, not to smoothly oscillate in direction. You would expect intensity variations, not directional wobbles. The smooth, continuous oscillation requires a mechanism that can actively change the direction of mass ejection over time scales of hours. In engineering terms, this is called thrust vectoring. It is what spacecraft do when they need to change the direction of their rocket exhaust without physically rotating the entire craft. They use movable nozzles or vanes in the exhaust stream to redirect the flow. The wobble pattern observed by Hubble looks exactly like what you would see if the three jets were being actively vectored through a repeating pattern. Swing left, swing right, repeat every 7.1 hours. That is not geology. That is not random outgassing. That is controlled behavior. Now, let me introduce another observation that makes this even stranger. The Hubble images from February also show variations in the relative brightness of the jets over time. When astronomers measured the intensity of each jet at different points in the observation sequence, they found something remarkable. The jets do not maintain constant brightness. Their intensity varies in a pattern that correlates with the wobble. Specifically, when a jet is at maximum deflection in one direction, it tends to be brighter. When it swings back to maximum deflection in the opposite direction, it dims slightly. This brightness variation is not huge. We are talking about changes of 10 to 20% in intensity, but it is measurable, consistent, and synchronized with the directional wobble. This suggests that whatever mechanism is causing the directional oscillation is also affecting the mass flow rate through the jets. More material is being ejected when the jet points in certain directions. Less material is ejected when it points in other directions. That is exactly what you would expect if there is active control over the propulsion system. You vector the thrust to change direction. You modulate the flow rate to change the magnitude of thrust. Together, these allow you to navigate in 3 dimensions. It is basic spacecraft maneuvering, and it is what the Hubble observations appear to be showing. But wait, there is more. The February Hubble images also captured detailed views of the antisolar jet, the fourth jet that points directly toward the Sun. Remember, this jet has been a source of intense debate since it was first observed. A comet tail pointing toward the Sun is physically impossible under normal circumstances. Solar wind and radiation pressure always push material away from the Sun, not toward it. The only way to create an anti-solar jet is to actively propel material in that direction against the natural forces. The new Hubble images show that the anti-solar jet does not wobble. While the 3 symmetric jets oscillate back and forth with their 7.1-hour period, the anti-solar jet remains fixed in direction. It points constantly and precisely at the Sun without deviation. This is extraordinary. If all 4 jets were produced by the same geological or outgassing processes, you would expect them all to show similar behavior. Either all of them should wobble or none of them should. But instead, we have 3 jets that wobble in perfect synchronization and 1 jet that remains rigidly fixed. This suggests 2 different systems operating on the same object. The 3 symmetric jets appear to be part of a maneuvering or attitude control system, wobbling in a pattern that could be used to adjust orientation or trajectory. The antisolar jet appears to be a separate system with a different purpose, maintaining constant direction regardless of the object's rotation or the wobble of the other jets. In spacecraft design, this is exactly the configuration you would use. You have main propulsion that provides constant thrust in a fixed direction for trajectory changes or sustained acceleration. And you have attitude control thrusters arranged symmetrically around the craft that fire in coordinated patterns to control rotation and orientation. The anti-solar jet pointing at the Sun would function as main propulsion, allowing the object to decelerate or adjust its orbit. The 3 wobbling jets would function as attitude control, allowing the object to maintain stable orientation or to slowly precess for navigation purposes. This is not speculation about what such a system might look like. This is a description of what the Hubble observations actually show. Now, I want to address the argument that some scientists are making to explain this through natural processes. The proposal is that 3I Atlas has an irregular shape and an asymmetric distribution of internal mass. As it rotates, this causes the rotation axis to wobble, a phenomenon called nutation. If the surface vents producing the jets are fixed to the body, they would appear to wobble in space as the rotation axis precesses. This could potentially explain periodic directional changes in the jets. But there are several problems with this explanation. First, nutation typically occurs on much longer timescales than 7.1 hours for an object of this size. You would expect precession periods of days or weeks, not hours. Second, nutation would cause all jets to wobble, including the anti-solar jet. The fact that one jet remains fixed while the others wobble is inconsistent with body nutation. Third, Nutation would not explain the brightness variations that correlate with jet direction. Changes in rotation axis orientation do not affect the rate of outgassing from surface vents. And fourth, even if you could explain one jet wobbling through nutation, explaining three jets wobbling in perfect synchronization while maintaining exact 120-degree spacing requires extraordinary fine-tuning of multiple parameters that is statistically implausible. The natural explanation requires so many coincidences to align perfectly that it becomes less probable than alternative explanations. So what is the alternative explanation? The one that no major space agency wants to state explicitly, but that an increasing number of researchers are discussing privately? 3I Atlas is an artificial object with active propulsion and attitude control systems. The three symmetric jets are thrusters firing in a coordinated wobble pattern to maintain or adjust orientation. The anti-solar jet is main propulsion, maintaining constant direction for trajectory control. The 7.1-hour period represents the program cycle time of the attitude control system, not the rotation period of a natural body. And the geometric precision of the jet spacing, the coordination of the wobble, and the stability of the anti-solar jet are all features of deliberate design, not accidents of nature. I want to be very clear about what I am and am not saying here. I am not claiming with absolute certainty that 3I Atlas is artificial. Science requires evidence, and while the evidence is compelling, it is not yet conclusive in the formal sense. What I am saying is that the Hubble observations of the triple jet wobble pattern are extraordinarily difficult to explain through any known natural process, and they are completely consistent with what we would expect to observe if the object has active control systems. At some point, when the list of natural explanations that do not quite work becomes longer than the single artificial explanation that accounts for everything, we need to seriously consider that the simple explanation might be the correct one. Occam's razor is a principle in science that states the simplest explanation that fits all the data is usually the right one. For months, we have been constructing increasingly complex natural explanations to account for the properties of 3I Atlas. Maybe it is a comet with unusual composition that produces jets through exotic outgassing mechanisms we do not fully understand. And those jets happen to be geometrically symmetric by coincidence, and they wobble in synchronization due to complex rotational dynamics, and the anti-solar jet is maintained by some unknown process, and the radio signals were random noise that happened to match prime numbers, and the 4% albedo is just unusual surface weathering, and the hill radius targeting was a mathematical error. Or maybe it is a spacecraft. Which explanation requires fewer assumptions? Now, let me address what happens next and why the coming weeks are critically important. 3I Atlas is currently moving outward through the solar system toward its March 16th encounter with Jupiter. Multiple observatories are tracking it continuously. Hubble will conduct additional imaging campaigns. Ground-based telescopes with advanced adaptive optics will observe the wobble pattern from Earth. If the wobble continues with the same 7.1-hour period, that will be additional confirmation that this is a real, persistent phenomenon and not an artifact of limited observations. If the wobble period changes, that will tell us whether the system is adjustable or responding to changing conditions. If the wobble amplitude increases or decreases, that might indicate active adjustments to the control system. And most importantly, if the trajectory of 3I Atlas deviates from purely gravitational predictions during the Jupiter encounter, we will have definitive proof of propulsion capability. Because here is the thing about wobbling jets. If they are just outgassing that happens to look coordinated, they should not significantly affect the trajectory. Comets outgas all the time without major orbit changes, but if they are active thrusters, even small thrust levels, applied continuously over weeks, will produce measurable trajectory changes. The March 16th Jupiter flyby will be the test. If 3I Atlas follows the exact path predicted by gravitational calculations alone, then whatever the jets are doing, they are not providing significant thrust. But if it deviates by even a few hundred kilometers from the predicted path, that proves the jets are doing more than just venting gas randomly. That proves active propulsion. That proves control. And that changes everything. The Hubble observations of the triple jet wobble are the latest piece of evidence in a growing body of data that suggests 3I Atlas is unlike anything we have encountered before. Not just unusual, not just interesting, not just anomalous, fundamentally different in nature from natural objects. Every new observation was supposed to resolve the mystery. Every detailed image was supposed to provide the natural explanation that would allow us to classify this object and move on. Instead, every new observation deepens the mystery and raises the bar for what a natural explanation would need to account for. We are past the point where simple coincidence can explain everything. We are approaching the point where the evidence will force a conclusion that many in the scientific establishment are desperately trying to avoid. The February Hubble images of the wobbling jets may be remembered as the observation that made denial impossible. The image that showed, beyond reasonable doubt, that we are watching something that was designed, something that is being controlled, something that is not from here. The wobble is not random, the geometry is not accidental, the coordination is not coincidental, and the implications are profound. Pay attention to what comes next, because the truth about 3I Atlas is being revealed one observation at a time, and we are running out of observations that can be explained away.